Mine didn't work. So I thought that I did it.
A lot of times, it's just as simple as forgetting to write a negative. I mean, it's sometimes something like that. So here I get 5x, 9z is negative 12. Yeah, so then if I do the same basic idea, I don't have to do any scalar multiplying to eliminate the y values between the second and the third ones. So I'm just going to rewrite. And I'm going to get, let's see, 2x minus y plus 4z is negative 8. Negative 3x plus y minus 2z is negative 1. And again, what I'm going to wind up doing here is just going to add them together. So negative 1x plus 2z is negative 9. Everybody okay with that? It's just, when you're working with systems of equations, it's always a matter of what do you think is the easiest way to go about it. Substitutions when you have three variable stuff is a pain. But if you can eliminate one of them, that's what I'm looking for. See opposite signs with the y's, I know I can do some scalars and go. So now I have two equations, two variables, one of which I can use substitution real quick. If I add x over and add 9, I get 2z plus 9 is x. Personally, I always thought that using a substitution, if it's possible, is always pretty simple because there's not much work involved. So now I can just say that in the other equation, 5 times 2z plus 9 plus 9z is negative 12. And with any luck, so it's 19z is negative, what is that, 57? Was that 3?
Yeah.
Negative 3. So I have a negative 3 for z, and then I just start working backwards. So negative 6, so it's 3. So now I have an x and a z. What do you do to find y? Well, you just substitute back in again. So we have 3 and negative 3. Does it matter which one I choose? I'll do the bottom one since the y just has a coefficient of positive 1. So we have negative 3 times 3 plus y minus 2 times negative 3 is negative 1. Negative 9 is y plus 6. What is that? Y is 4, I believe? No. Negative 3. Negative 2, yeah. And there's your order triple.
Can you please tell me why what I did didn't work?
How much would I bet you missed a sign?
I keep checking it. Right here.
Every time I can. I got let's see.
What? What?
This isn't 27, it's 2z.
Oh.
Here's what I want you to do. Put that slash line in the diagonal part of the z.
Yeah.
There you go. A z is not a 7.
I
Yes,
got,
ma'am.
Z was like negative 3 if I was supposed to, but I don't know how to substitute it back in to find x.
Oh, we already had z here. Here I already had x in terms of z.
Yeah, I know, but I didn't do it that way. Like the equation I had was 'Cause I don't know how to do your
See-
way, so I.
Did you use this elimination of this? I mean, you should still get the same results. You really should. You
Wait.
really, really should.
No, I didn't think it was 27.
Yeah, you did.
No, it didn't. Look
Because
at
you
it.
moved it over and you
I
tried to
moved it
divide.
over, and then I put 16 plus 2z, 5y equals 16 plus 2z, and then divided by 5.
Oh, why would you do that?
Why wouldn't I do that?
Why would you do that, Emma?
I don't get where to go from here then.
You just leave it at this one. Then you do the same. You have two variables. So now eliminate x in that first equation, and then just you have two equations with two variables. You're making it too tough on yourself doing all that. You're making it way too difficult.
Why didn't that work?
It should, but don't do that anymore.
I don't understand how to do it then.
Hey,
What's that,
we're,
like,
we're
why
using
does that work?
we're using some sort of a linear combination and all that kind of stuff. This is the easy way to do this. What you don't want to do you really don't want to do substitutions when you have three equations with three variables, unless one of them is already like one variable. That's it. Because what happens there if you're using that substitution where you by moving them around, you had something like this, or I'm sorry, here, where you would have x is negative 9/5 z minus 12 over 5. I don't want to put that nasty fraction into something like this. In theory, it should work, but you're just making it so difficult on
So
yourself.
then what do you do when you?
See how let me pull up the next one. And again,
Because the next one I started doing it and it like got all ugly again. And I didn't know what I did wrong.
on the
I
next,
ended up getting 18y equals negative 15z minus 11.
That answers either.
when I'm looking at this is 37. That was the only one we had to do, right? My objective here is that I want to pick a variable to eliminate, and I want to think of a method that is going to be relatively straightforward without a lot of heartache.
So could you multiply the bottom one by negative 3 and then put it with the middle one?
I wouldn't even, you could do that, but here's what I would suggest before I get too crazy into this stuff. Yes, ma'am? You can, but then you wind up with it just winds up being a lot more work. When I see this, I notice right in the middle, I have alternating signs. Everybody see that? One of them's positive, the other two are negative. Which means I can do some sort of a linear combination, which means I'm going to get a scalar to eliminate the y values for the top equation and the bottom equation. So if I'm looking at this, I'm going to try to find a GCF, or an LC, least common multiplier, whatever you want to call them, between a 3 and a 2, between a 3 and a 5. So what I'm going to do is I'm going to multiply the top equation by 3, middle equation by 2, and I get this. 12x minus 6y plus 15z is 18. That's by multiplying the top one by 3. I'm going to multiply the bottom one, or the middle one then, by 2. 6x plus 6y plus 16z is 8. By doing that, by not multiplying by negatives, I don't have to worry about distributing all that stuff out. I'm trying to figure out an easy way of doing it so I can just add. Whenever I see alternating signs, if I can add things together without having to mess around with it, it's just easier. Okay? It's a lot less work on yourself as you go through that. Okay? So from here, by adding those two together, what happens to the y's? They go. So 12 and 6 is 18. 15 and 16 is 31. 18 and 8 is 26. Two variables, and now I'm going to do the same thing to get another equation. So I'm going to eliminate the y value, again, between the second and third equation. What are the scalar multipliers I'm going to use? What do I have to multiply this one by and this one by? Yeah. So by doing the middle equation now by 3, thank you, by 5, and the third equation by 3, I'm going to have a 15 in the middle. Add them together, they go away. And I have it in terms of x's and z's then, without having to do all that extra substitution steps. Scalar it out, we get what? 15x, 15y.
Plus 40z is equal to 20. And the bottom is 3x minus 15y minus 9. And then equals 15.
Okay.
So we need 15.
So if you add those two together, you're fighting this way, aren't you?
Well, what do you do after you get 18x plus 31z equals?
Well, we'll see. Okay. Oh, sorry. Okay.
There is no solution.
So now, make sure I multiply by 5. Yep. 15. Okay. So now, what happens?
There is no solution. There will be class.
When you get to this part, yes. If you brought them together, if I subtract all this out, I get 0 is what, -9?
Yeah,
Is that a true or a false statement?
false statement.
It's a false statement,
There's no solution.
so this is a no solution.
That's why I was fighting it.
Because you can wind up, this, I mean, and that's the idea here. I mean, it's possible. It's totally possible. This stuff happens, guys. So, one of the other things I wanted to show you with this, what was it, 172? I forget which number it was that this book did.
I'm confused though. Why wouldn't you like try to like solve for x or solve for z or something? After you
Well,
did?
what happens, as soon as I have the same,
Then you can substitute it back into an equation for x or z.
you can, but no matter what happens here, if I subtract them together, they're automatically eliminated. So I have no solution here because x and z's go away.
So right after you get like that, then you just start doing another one.
Like the
Like,
next
right
problem?
Yeah, like right after. No, like right after you get 18x plus 31 equals 26, then you like automatically just like pair up to other equations. You don't
Yeah.
like try to solve for anything.
Correct. Because what you're trying to do here is you're trying to take a big chunk to a smaller chunk. All right? You're trying to eliminate, you're picking out of the three of here, what's going to be the easiest way to eliminate one of the variables. And by doing that, you're going to have to do that twice. Because you're starting a three-way, a three by three system.
So
You're
then
trying
you
to get
turn
down to a
it.
two
So
by
then you
two.
turn it, making it into like just like there's been two systems
Correct.
that we started with.
Yep.
So now we have to you actually have to find it, there's an actually answer.
There is no answer.
Oh, okay.
This is a no solution.
Okay, good.
The reason it winds up being no solution is because you wind up with a false statement. What happened if this wound up being 0 equaling 0?
Oh,
Right. And then it's everything would work. Okay. That kind of stuff does, and that's kind of one of the reasons why I wanted to throw one like this at you. Okay. Now, the other thing that I wanted to show you, well, let's see, we have half an hour or so. Okay, cool. Make sure your name's on that. Send that up, and let me show you another little trick thing here, because within this 3-5, yeah, there was what 5 problems I think. 4. Was it 4 or 5?
30, 32, 34, 35.
Yeah, there are 4. So the other thing that works out rather well with these things is that there is a way for us to be able to do the work and then check to make sure we're not a bunch of smokes and doing it correctly. Yeah, absolutely.
We go over 30, 32.
So let me look at, actually I don't know why I write this down. Let me do this. This is what I want to do there. I want to do, I want to put in here real quick, and I want to show you guys you guys this nice little trick for when we're setting up systems. Get the desk up here.
Mr. Murphy, you need like one of those like donut cards.
Yeah.
Or like one of those like food menu cards.
So I want to show you guys a way that you're able to look at your system of equations and then be able to verify that you are correct. So I want to show you guys a way that you can check your answers knowing for certain that you didn't done goof. So I want to start again by using some means of eliminating one of our variables and going through it. But first, let me write it all out. So what is it? X minus 4y plus z is 6. 2x 5y minus z is 7. And 2x minus y minus z is 1. Now that we've kind of gone over this again, which one of those variables do you think is going to be easier to eliminate? The z's will. And the reason why the z is going to be easier to eliminate, because notice 2 of them are negative and 1 of them is positive. So I'm going to take this top equation and add it to the second one, and then I'll add it to the bottom one. By doing that, I will eliminate z. Pretty straightforward?
Yeah.
Okay.
It's almost too straightforward.
I'll do that again. Okay. So we have these two to add together. So let's see, 3x plus a y is 13. Here we have 3x minus 5y is a 7. I can go substitution, I heard someone say that. Or, what can I do real fast? What's that? Subtract. If I subtract them, if I subtract these two together, what eliminates? The x. Now, you could do substitution, get y by itself and substitute through. There's nothing wrong with that. But as soon as I saw that I had the same coefficient with the same sign, I can subtract. I'm not usually a big fan of doing the subtraction, especially when I have double negatives. A lot of times people forget that. So you wind up with y minus a negative 5, which is 6. So y is 1. Now you have y. It's always funny when people in the back have to stand up. That means move it up. So if y is 1, substitute back in again. What are you going to get for x? 4. So I have 3x. So we're on our way now. We have 4, comma 1, comma, to find z. So if this is 4, this is 1. What's z? 6. So that's a lot of work, isn't it? But like you said, it almost seemed too easy. What if there was another way that you can do? I don't know why I close that anyway. What if there's a way that I can show you guys that you can actually check your work via a calculator? You'd be intrigued. So what happens is when you're dealing with matrices, or I'm not matrices, excuse me, a system of equations. Systems of equations we can rewrite as what's called a matrix. A matrix is what we're going to look. You ever seen those before? The matrix is something like this. It has rows that go across, and we have columns that go up and down.
columns. And
Sure. That's why I teach math. It's a lot less vocabulary. So you have rows because when you row a boat, you have to be horizontal. Because if you're rowing a boat vertically, you're going to die. Because you just went over the waterfall of death. Anyway, so what happens is that you can take, if I take something like this, what are the coefficients on the left-hand side? 1, -4, 1. 2, 5, -1. 2, -1, -1. Are we okay with that? What I can do is I can place them in what's called a matrix, a coefficient matrix. 1, -4, 1. Two.
Yeah, we something like that.
If Johnson's got something.
She's fun.
I love her.
I had both her kids too. What you can do then, let me ask you this. When you work with, let's do something that when you are solving a one-step equation, what's the operation called when you try to undo something? You guys remember what that's called? When you undo something, you take its inverse operations. What's the inverse of adding? What's the inverse of multiplying? What's the inverse of square rooting?
Square?
Sure, I'll give you that one. Square rooting. So the inverse operation here would be to subtract 7, and you get p would be -3. So you can still use what's called an inverse operation of a matrix. On your calculator, there's an inverse button. Do you know what it is? The -1 button. The -1. Yeah. Because if you take 2 to the -1 power, that equals 1/2, which is the inverse of 2. Everybody see that? The -1 button. X to the -1, that's inverse. So, would you also believe if I told you, I know you guys are going to freak out.
Wait, what do you have to put second mode or something?
For what? The inverse?
For the -1 button.
It's the X to the -1. It's right on the.
Just click it.
Yep, that's it. But if you just have to put a number in front of it. Yep. Use it as a decimal number, that's all. What I'm going to show you guys is that you can create what's called a matrix in your calculator. I believe the shortcut key is alpha zoom. Yes, alpha zoom. And what we're going to create is going to be a 3x3 matrix. 3 rows, 3 columns. So we just have to move our cursor up. And then we click OK. And you get that. Everybody have that so far? Now, what's nice is that if you type it, there's a book there. What's nice is that, let's say the stuff that we're going to do is all going to be what's called a square matrix, because we're talking about 3x3s or 2x2s, and if I get crazy, you'll give you a 4x4, because it's just buttons. We'll do this stuff by hand at the end of the school year. So I'll give you all the fun shortcut way now, and then at the end of the school year, you'll just be mad at me, and I'll be okay with that. What we're going to do is we're going to put in the coefficients. 1, you got to hit the right arrow though. When you type these in, make sure you use the negative button, not the minus button for your negatives. Okay. So now, in order for us to make this work, matrices have a way of to solve them. We use their inverse properties. Well, instead of having you guys figure out what the inverse is of that, which is actually really easy to solve for, we go ahead and press a button, especially when we're just solving equations. So for this case, what we would do is put it to the -1 power. by doing that. But that means I have to multiply it to something. I have to multiply it now by the, what we call the solution matrix. These guys. How many rows does that have?
One.
Three.
Three rows.
And one column. So what we do is we multiply it by another alpha zoom. We have to change it. It's 3 rows, 1 column. And what's nice is that if you accidentally do 3 columns, 1 row, it'll show you a blank one. You say, oh, nuts, I just did it. You just have to retype it, that's all. So I want a 3 by 1. And then I click OK. Should I hit it 2 times? And now I have that. 6, 7, 1. 6, down, 7, down, 1. Press enter. There's your answer. 4, 1, and 6. And it puts it in the order of X, Y, and Z. So, is that a nice, neat way to check, make sure you did the work right? It is, but it can also verify you did it correctly.
Wait, where'd you get 6, 7, and 1?
The solution. It's the column, the solution matrix. So when we're doing, if we ever want to double check our work, or to put things through, make sure you're setting them up correctly, it's very simple to put this into a calculator, right next to each other, and that's how you can double check that you didn't done goofy. Sir.
Would this work if there were like only 2 parts to the equation?
Like a 2 by 2?
Yeah.
Yeah. Yeah. Yep, you just change the matrix. I don't think this book gets too crazy with matrices. They actually talk about it in section 3.6, how to find determinants and stuff like that, and how you can work through things. But to be honest with you, the most important thing about being able to solve with matrices is to actually be able to do this stuff, because it is so fast to work with. Where was that? But yeah, you can do so many cool things. So let's do this then tonight. I'm going to give you more of these. And then that way you can bounce back and look at your matrix to verify that you did it correctly. So which ones we did? We did 34 and 37. Yeah. Let's do 33, 35. 40 and 41. Yeah. Let's do those. Same page, 172. Let's do those, and then that way you can use the, I want you still to do the work, but that way you at least know what your number should equal when you're done. Is that fair?
Yes.
Matrices are kind of cool. I'll put this up here if you guys want to take a picture real quick. Yes, ma'am.
Can we go over numbers 30 and 32 of the one? Or can you go over those? Actually, like I said, I got like half.
Oh, do 42 also. I'm sorry. I forgot to put that one on there. 42 also.
30, 33, 35, 40, 41.
So I get 5. All right. Oops. There it was. There, if you guys want to start them up. Okay?